So this is Z, this is Y, and this is X.
Cartesian.
Yeah? What shape is this? Sphere, cone, paraboloid, cylinder. Okay, what shape is this?
Cylinder.
Cylinder.
Para-
The answer is paraboloid, it's not cylinder. Because usually if cylinder, they will give you an equation something like this. X squared plus Y squared equals to 4. Something like this. Okay, so they will give you the equation of the circle, okay, of the base of the cylinder. Okay, so this is actually a paraboloid. Okay, a paraboloid. So you can actually try to sketch this shape out, okay, by assuming, for example, when the for example, when the z is 1, okay, when the z is 1, you will be cancelled out, so you get a point here, something like this. Okay, when you reduce the height, okay, or you reduce the value of the z, okay, for example, when the z is 0, okay, you will get a circle somewhere here, right? Okay, and then the shape, you can assume either the x is 0 or y be 0. Okay, you assume one of it to be 0. For example, if the y is 0, you could get your z equals to 1 minus x squared. Okay, so you have a square, so meaning that, okay, this will be a curve, okay, instead of a straight line. So it is a paraboloid. Okay, so now you have this surface. Okay, this is the sigma, this is the surface. Okay, and the flux, okay, just imagine the flux, okay, is in the upward positions. Okay, and this is your f. Okay, the f has been given. Okay, so you have to find the value of the flux coming out from this surface, paraboloid surface. Okay, so we look at the solution. We look at the flux equation that we are going to solve. So this is the flux equations that we are going to solve. Okay, we'll talk about it yesterday. Okay, so we look at each of the parameter one by one. F. Okay, so F has been given. Okay, F has been given. N is not given. They just tell you that the N is upward. Okay, the N is upward.
Sorry,
Okay.
Majid.
Yes.
Ada orang nak masuk je ke room.
Oh,
Ada
dah
question.
masuk. Okay, dah masuk Right. Okay. So okay, where is stop? Okay, we talk about the n. So this unit vector normal n. Okay, so the question tells us that it is upward. Okay, in the upward position, so you can look at your equation upward. What kind of equation you have to use? Okay, so if it is upward, you have to apply this equation minus fx. Okay, minus fy. Okay, 1, this is a positive 1, divide with fx square plus fy square plus 1. Okay, so this is the equations that you have to use to find the unit normal vector. Okay, unit normal vector. Okay, so when you look at this equation for unit normal vector, okay, so this term is telling you that you need to differentiate with respect to x, you need to differentiate with respect to y. But what function to be differentiate? Okay, what kind of function that you need to differentiate? Okay, so you have to look at the surface. Okay, what surface you have in these questions? Okay, so the surface you have in this equation is a paraboloid, which is equation has been given 1 minus x squared minus y squared. Okay, so this is the equation of the paraboloid. Now you need to perform the fx and also the fy. Okay, so just differentiate with respect to x and differentiate with respect to y. Did we talk about this example yesterday? Atau tak we discuss this example? yesterday. You know, right? Okay. Okay, continue. So find the differentiations. Okay, so this one will be equals to negative 2x. Okay, and the fy is negative 2y. Okay, so complete. Now you put this answer into the equation of unit normal vector. Okay, so you have negative, so you have 2x. Okay, and you have a 2y. Okay, and you have 1, right? Okay, so just follow here. Just follow here. Okay, just follow this part. Okay. Next. Okay, so this part I prefer to just write it back again because at the end we will cancel it out. Okay, so I don't want to replace anything here. Okay, so you complete your n. See, this one you already complete. Okay, now is the dx. Okay, so yesterday I already explained to you what is dx. Okay, so dx in this case is equals to fx squared plus fy squared plus 1 and dA. Okay, right. So when you combine this ds, okay, you only combine this dx with the f and also the n term here, okay, it will be cancelled out. Okay, so I will write it again, okay, so that you have better imagination. So f, what is f? Okay, our f is what is my f? F is x, y, z. Okay, x, y, z. And dot product, okay, with this n. 2x, 2y, 1, and this one. Okay, so this is my n. And my dx, okay, I just write it. Okay, this is equals to this one. And dA. Okay, dA. Right, dA. Okay. Right, so I put everything together. So I can cancel this thing. And then I perform the dot product. So here I get 2x squared plus 2y squared plus z. Okay, right? See plus z, and dA. And dA. Okay, dA. Okay. So next step is we have to decide the dA. Okay, but before we decide the dA, we see here we have a z. Okay, we have a z component. Okay, so this z component can be replaced by the functions of a paraboloid. Okay, so 2x squared plus 2y squared plus z. Okay, so the equation of the paraboloid in the question is this one. So we just put this in here. And regarding the dA, A stands for the area. So you have to look at the surface that the flux coming out. Okay, so look at the surface. Flux coming out. Okay, so what surface we have? We have a paraboloid surface, which is this one. This is a surface. Okay.
Circle.
Yes. Betul Okay, jika ada orang nak join lagi, just tell me Okay, so this is a surface. Okay, so if you want to decide the dA for the surface, you need to choose projections. Okay, you need to choose projection like what we have done before. Okay, So you need to choose projection. Okay, so we will choose the XY projection. Choose XY projections. Why? Because for XY projections, it will be very clear that it is a circle. Okay, it is a circle when you choose the XY projections. And what is the value? What's the radius of a circle? Let's have a look. Okay, so when you go to the XY projection, basically you will see this circle. Okay, so this circle is located at the position Z equals to 0. Z equals to 0. So if you want to know the radius, okay, this is the equation of your paraboloid. When it is at position 0, okay, you will have these equations. And when you rewrite it, okay, you can see that this is the equation of the circle with radius 1. Okay, with radius 1. Okay, so here, obviously, we will pick the polar coordinate system, okay, for our dA. Okay, polar coordinate system. So I will pick R, dr, and d theta. Okay, clear? I hope you're clear on how I actually pick the coordinate systems for the double integral. Okay, it is based on the projections. Right, so this is a circle. So we are sure that for the circle, the radius dr will be from 0 until 1 in this case. D theta will be 0 until 2 pi. Okay, so just fill up the interval. And before we could start to solve this thing, I think we need to convert, right? We need to convert because we already decide to solve using the polar. Okay, but here we will still see some x, y, which is something that we don't want. Okay, we don't want it. Okay, so let's change it to the polar coordinate. Polar coordinate. So this one, I could write it to be 2r squared, right? Plus 1 minus r squared. Okay, so you have r, dr, d theta. Okay, so you could simplify again before you start to use your calculator. So here will be equals to r squared plus 1 and r dr d theta. Okay, it's up to you whether you want to multiply this thing inside or not. Okay, it's up to you. If you don't want to multiply it inside, and if you want to straight away press the calculator, also no problem. Okay, so you can press the calculator. Okay. So for this part, you will get your answer 3/4 d theta. And lastly, it will be 3/2 pi. Okay, 3/2 pi. Is this clear for you?
Yes, madam.
Clear, right? Okay, we move on to the next question. Might be we could try question number 2. So the question number 1 is just about calculating the flux coming out from the surface. And for question number 2 that we are going to try is about verified divergence theorem. Verified divergence theorem. So this is question number 2. Okay, same exercise 4J. So you have to verify the divergence theorem. Okay, so this divergence theorem is a theorem of formulations for us to calculate the flux coming out from the solid. Okay, so the difference between the surface integral of vector field And this divergence theorem is, okay, divergence theorem focus on the flux from the solid, okay, whereas the surface integrals of the vector field will focus on the flux coming out from the surface. All is different. So this is the surface integrals of vector field. Okay, flux coming out from the surface. Flux from surface. Okay, and the divergence theorem is you calculate the flux from what? From the solid. Okay, so this is the formula. This is the flux from solid. So we could we could say that the divergence theorem is actually a transformations, okay, from the surface integral to the volume integral. Okay, so this question is asking us to verify. Verify meaning that you have to do both sides. The left hand side, you have to calculate the get answer. And for the right hand side also, you have to calculate and get answer. And you must make sure that both answers are the same. Then only you could verify. Okay, clear? Okay, so we go to question 2b. 2b, we try 2b. B, this one actually B. Okay, so sigma be the surface of the sphere. Okay, so this one is a surface of a sphere. Okay, and this sphere has the equations x squared plus y squared plus z squared equals to the a squared. So the a squared represents the radius of this sphere. Oriented outward. Okay, so I just record this thing as outward. And the f is equals to 0, 0, z. Okay, so this is the force. Okay, so this is the force. Okay, so now let's solve for the left hand side. Left hand side. Okay, so left hand side. Okay, so left hand side is you have to solve this thing, right? You have to solve for this one. Okay, so we have to find the f, or f is given, and we have to find this thing, and then we define the interval. Okay, so we go through the same process like the first questions I explained. Okay, so this one is the outward. It's the outward flux. Okay, so we'll be using these equations. Okay, everybody understand why I want to use this equation? Because it is outward. Okay, so it is outward. Okay, that's why I pick these equations. Next is to find the f. Okay, because we need to perform differentiations. Okay, so what surface we have? We have a spherical surface. We have a spherical surface where is z. Okay, is equals to a squared minus x squared minus y squared and square root. Okay, so you might be asking where this thing is from. Okay, so this one is the equation of the sphere over here. So if you keep your z at the left hand side and if you move the y and x to the right hand side, and then you could get this thing. Okay, so this is the equations of the sphere. And in fact, the equation of the sphere, you can have two, right? One is positive, the other is negative, right? Okay, because this is upper hemisphere and this one is a lower hemisphere. Okay, so we only just do one because both surfaces are the same. Okay, so the flux that we compute, okay, from the upper hemisphere will be the same as the flux, okay, from the lower hemisphere. So at the end, we just times 2. Okay, we just times 2, we could get. Okay, so we just do one. Just do one. Okay, just do once. Alright, so we got the fx. We want to perform the differentiation with respect to the x already. Okay, so I hope you know how to perform a differentiation for this kind of equations. Okay, so you could rewrite it to be a bracket 1 over 2. It's the same thing. Okay, so when you perform a differentiation, you could bring the 1 over 2 in front. Okay, whatever inside the bracket, you just write it down again. Okay, so the power is 1 over 2, and this 1 over 2, you need to minus 1. So you get negative 1 over 2. Okay, next we focus on the parameter in the bracket. Okay, we differentiate with respect to the x, so we get 2x. Okay, make sure you know how to perform a differentiation. Very, very important. Otherwise, you cannot continue. So you must make sure you know how to do it. Okay, square root. So you have the x squared, y squared, and square root. Okay, so this is your fx. Next, about the fy. So fy is very similar to the fx. Okay, so just the last term you have to differentiate with respect to the y. Okay, so I will just write out the answer directly because the front part is the same. Okay, front part is the same. This is your fx and fy. Okay, fx and also the fy. Okay, what is the next step? So next step is to replace it into the equation of unit normal vector. This one. Okay, so we put it inside. So remember we have a negative, right? So plus the negative here, you will get positive. Okay, this one will be y over okay, and here will be 1 divide. Okay, here I'll just put this thing again. It's a general one because it will be cancelled out. Okay, so now combine with the f. What is my f? So my f is a 0, 0, z, right? Dot product with this thing. Okay, so I will just cancel out directly. Okay, so you have the x. So at the end it will be 0. Okay, so y. One. Okay, then we have a d8. I cancel out directly. Okay, I can start out directly. Okay, so because these two, they are 0, so it will become very easy. Right, so you just left the Z, dA. Okay, Z, dA. Now we need to define what should be our dA. Okay, so we are actually doing the flux for the upper hemisphere. Upper hemisphere. So the upper hemisphere, okay, let me draw it. The upper hemisphere should look like this. Upper hemisphere. Upper hemisphere. Okay, right, upper hemisphere. Upper hemisphere, and this is A. A, and also the A. Okay, upper hemisphere. Okay, so if we want to define the dA, dA means that we have to refer to projections. Okay, so the easiest projection will be XY projections because we could see a circle here. Very clear that this is a circle with radius A. Okay, so let's pick the polar coordinate for this case. And for the Z here, we have to replace with the equation of the upper hemisphere, which is a squared minus x squared minus y squared. Okay. And here will be r, dr, and d theta. Okay. Which is from the xy projections. Okay. So the r will be from 0 to a, right? You can look at the a is the radius, and 0 to 2 pi for the angle. Okay. Next step is about conversions. Okay, because you are going to solve in the polar coordinate, so it will be s squared minus r squared, and you have the r, dr, d theta. The r is not included in the square root. The r is not included in the square root. So we need to solve these integrations. Okay, we cannot press calculator because we have the interval a over here, variable constant a, so we cannot press calculator. So we have to use the manual solutions. Okay, manual solution. Here we could use the substitution technique. Okay, substitution technique. Okay, substitution technique. So for this substitution technique, you are going to substitute, okay, the parameter here, okay, with a simple variable. Okay, for example, I decide to replace, okay, my a square minus r square with u. Okay, so that the whole thing here will become square root u. Square root u. Okay, so when I replace it with a u, okay, I have to differentiate with respect to the u. Okay, I have to replace my dr first also. Okay, so in order to get this done, I have to find the du dr. Okay, so the du dr will be equals to negative 2r. So the du, okay, the du would be no, should be stated the dr. Okay, the dr, because I want to replace. So the dr would be du over negative 2r. Okay, just change their positions. Let's simplify and change their positions. Okay, so let's see what happens if I apply this substitution technique on my integral with respect to dr. So I have this integral. So I have a square root u, right? Okay, and the r is here. Okay, I read an r. dr, okay, dr is going to be replaced by the du over negative 2r. Okay, negative 2r. Right. So this is the d theta right here first. Okay, so this one could be cancel out. Right, you could cancel it out. So you left this. Maybe I just focus here first. I just focus here. This one first. Okay, I focus here. Okay. So now you have the u power 1 over 2. Right, and you have a constant negative 1 over 2 and du. Okay, you need to solve this integral. Okay, so u, okay, when you perform the integral, it will be 1 over 2 plus 1. All right, divide. So this when you plus 1, you get 3 over 2. This thing. And multiply with negative 1 over 2. Okay, so this is how you perform the integration. So you will have 2 over 3. Okay, multiply with negative 1 over 2. And your u is power 3 over 2. Okay, you could cancel this thing and get negative 1 over 3. Okay, u power 3 over 2. Okay, so you have done the integrations. You have done the integration, this part. Okay, but you haven't replaced the value yet. Okay, so now you replace, okay, the u with a square minus r square. You replace that. Okay, so it will be negative 1 over 3 a square minus r square and power 3 over 2. 3 over 2. You get this thing? So this is the outcome of performing the integration. Outcome after you complete the integrations, and you now have to replace it here. Yeah, you have to replace it here. So it will be 0 to pi. Okay, you have negative 1 over 3 a square minus r square. Okay, 3 over 2. And the interval just now is from 0 to a, right? Okay, you haven't performed this thing yet. Okay, so this one is just the integration. You know it's not yet replaced the value. Okay, so all the r you should replace it with a and 0. A and 0, right? So we do together. Negative 1 over 3 a square minus, if it is a, okay, you get this thing, minus 1 over 3 a square minus 0. So this one give you 0. This one could be cancelled out as positive. So it would be negative negative 1 over 3. No more negative, sorry. So you have a, this one can, and this one can cancel out, a power 3. Okay, theta. Okay, next step will be easy, right? Just top up with the 2 pi over 3 a cube. Okay, so you get the final answer is this one. And this answer represents the flux coming from the upper hemisphere. Right, upper hemisphere. Why is just upper hemisphere? And because here we just consider the equations for the upper hemisphere. Okay, for lower hemisphere, its equation will be considering the negative here. Okay, right. So if you want to calculate for the lower hemisphere, you have to repeat the process one more time. But in this case, you don't need to do that. Okay, because the upper hemisphere and lower hemisphere, they have the same surface, same shape, okay, same area. Okay, so we don't need to perform it twice. Okay, so the total flux just mentioned here, the total flux from the sphere, okay, would be 2 pi over 3a cubed multiplied with 2. Okay, multiply with 2. So it will be equals to 4 pi over 3a cubed. Okay, so this is the flux from the sphere. Is that clear? Okay. Right. So we just complete the left hand side. Guys, this is just the left hand side. Okay, we haven't complete this question yet because we need to verify. Okay, the right hand side. Right hand side. Yeah. So let's do the right hand side. See what long steps over here. Left hand side. Okay, we look at the right hand side. Right hand side. Yeah, right hand side. So right hand side, the equation is this one. The divergence theorems. You have the del F and you have the dV. Right. So the del F over here, you can find it. Right. It's a dot product. So the del is this one. So this represents the del. You dot product with the F. Your F is just a 0, 0, Z. Okay. 0, 0, Z is an easy one. Okay, so you will get 1. You will get 1. So you put this one into the triple integral. 1. Okay, next you have to decide what should be your dV. So you look at your surface again. It is a sphere. Okay, it is a sphere. So the volume of a sphere will be better. Okay, it will be easier calculated if you use the spherical coordinate system. Of course, okay, spherical coordinate system. So the dV here, you could use the spherical coordinate system, which is r squared sine phi, okay, dr, d phi, d theta. Okay, so these represent your dV. Yeah? Okay, dV for spherical. Okay, coordinate system. Spherical coordinate system. Next, okay, our job is to find the range, find the interval for dr, d phi, and d theta. Okay, so the dr in this case, okay, you can look at the equations. Okay, look at the equation. Where is the equations for the? Yeah, so this is the equations. Okay, so from here you know what is the A and what is the R. Okay, which is A. Yeah? Okay, so we can define it to be from 0 to A. Okay, the radius of the sphere. And for the phi, okay, phi is the angle start from the axis Z. Okay, start from axis Z, so 0 to pi. And theta is 0 to 2 pi. Do you still remember about the angle of the spherical coordinate system? Do you still remember? We have learned this thing in calculating the volume, right? The volume Okay, so I'll just continue. So for this integration with respect to the r, you have to do it manually because your interval has variable a. So this one you have to do it manually. R power 3 over 3. Okay, then you have a sine phi. Okay, you have a d phi and d theta. So this one. So you get a cubed over 3 minus 0. Minus 0, so I don't write it down. Okay, next is to integrate with respect to the theta. So this one you could press calculator. Okay, so this time this one will be a constant. Okay, just take it out. Okay, calculator, you just press this sine phi. Okay, sine phi. Okay, from 0 to pi. 0 to pi. So this one, this is a constant, so we'll write down this one. Okay, so you can get answer 2. 2, right? Okay, 2 d theta. And finally, okay, you have the integration with respect to the d theta. So you get 4 pi over 3 a cubed. So this one is the flux coming out from the sphere by using the divergence theorem. Flux coming out. Flux coming out. Okay, so you can compare the left hand side answer and also the right hand side answer. Both are the same. Both are the same. Okay, so from here you can say that, okay, the divergence theorem is verified. Okay, just make a conclusion saying that it's verified. So in the exam, please highlight where is the final answer. Okay, don't just simply do a lot of calculations and your calculation is jumping here and there. I cannot find where is the final answer. Okay, so you have a lot of papers in the exam, so use as many paper as possible and make sure that your writing is big, very clear, everything. You can just request papers. Okay, don't squeeze here and there. Okay, right. So any question for this one? Okay, you can see from the left hand side calculation and also the right hand side calculations. The right hand side calculation using the divergence theorem is much more easier. Okay, just like this, very short steps. Okay, whereas for the left hand side, okay, yeah, maybe we will spend a lot of time doing the integration, this part, okay, but if you compare it, okay, the left hand side calculation is much more longer, okay, compared to the right hand side. Right, let's try one more questions. Yeah, so we will have presentation also. Okay, this should be okay. All right, so we go to one more question for the divergence. We just do the right hand side. Okay, we don't need to do the left hand side. Okay, so we go to question 4a. Same exercise. Question 4a. Same exercise. 4a, yeah. Use the Gauss law theorem. Gauss law theorem and divergence theorem, they are the same. Okay, don't confuse. Okay, don't say that you didn't learn the Gauss theorem in class. Gauss theorem and divergence theorem, they are the same. So you have to use the Gauss theorem to evaluate the flux, okay, coming out from the surface. Okay, where the F is given by 3x, 4y, and 7z squared. Okay, so this is your F Okay, so sigma is the surface that cover G with outward vector n. Outward. So we just write down, even though we don't really need the outward information, because we are solving using the divergence or Gauss theorem. So G is a solid bounded by the surface and plane Z equals to A. So you have two surface. Okay, one is this one, 4x squared plus 4y squared. Okay, and then you have this one. Okay, you have this one. Okay, so let's draw maybe the solid first, so you can imagine, because later on we need to define the dV. Okay, so you must be clear about how does a solid looks like. Okay, so we draw this thing first. Okay, so how you should start. Okay, so it's Z equals to 8. Okay, so you have this solid. So let's see what kind of structure is this. You can assume that Z to be 0. What happened? Okay, if your x Z equals to 0, you could get 4x squared plus 4y squared equals to 0, or the x squared plus y squared equals to 0. So you get a point. Okay, you get a point. When you continue to increase this thing, okay, for example, you continue to increase to 4, for example. Okay, 4x squared plus 4y squared equals to 16. 16, right? Because I removed the square root. Okay, so x squared plus y squared will be equals to take out the 4, here will be 4, right? So it's a circle, radius 2. Okay, so when you have information something like this, you already can estimate what kind of shape is this. Okay, so you can draw this thing. Okay, when z0 is 0, okay, when the z equals to 4, you get a circle. Okay, get a circle. Okay, and it stopped at the z equals to 8. So in fact, you can stop at z equals to 8. Okay, so just imagine here this is 8. Okay, so now you have to decide whether this part is a curve or is a straight line. Okay, so you can assume x or y to be 0. Okay, so if the x is 0, you have the 4y squared, right? So it could be 2y. Okay, so it means that it's a straight line. Okay, it's a straight line. So 4 might be here lah. Okay, the circle 4 here. Okay, so this is your structure. So we go to the equation of divergence theorem. Okay, so asking us to solve this thing, dV. We solve this thing, right? Okay, so first thing is to find the divergence of this vector F. So this is the divergence, this is the del. Dot product, the F. What is F? Oh, F is this one. Okay. So here you get 3 plus 4, 3 plus 4 plus 14 Z. 7 plus 14 Z. Okay. 7 plus 14 Z. Okay. Next. Okay, we consider what equation, what the coordinate system you want to use for the dV. Okay, so you could use the cylindrical, you can also use the spherical. Okay, but for the spherical, you need to find out what is your phi by using a technique that we have learned in the book. Okay, here we cannot straight away assume it to be pi over 4 because the equation is different. Okay, for this cone, so it's different. So you have to search for the angle. Okay, if you want to use a cylindrical, you can just proceed with cylindrical dz r dr d theta. D theta. Okay, so this is the equation for the cylindrical. You need to find the dz range. Okay, so when you want to find a dz, always imagine yourself is sitting inside. When you refer down, okay, you are inside, you refer down, basically you can see, okay, this surface. Okay, so this is the equations of the cone. Okay, when you refer up and up, you can see a flat surface, okay, at the position z equals to 8. Okay, so based on this information, you could put your dz. Okay, so the upper interval will be 8, the lower interval will be 4x squared plus 4y squared. Okay, this is the equations of the cone. Okay, of the cone. When go to the dr and d theta, you have to look at its projections, xy projections. So when you look down from the top, okay, xy projection, you will see this circle. You will see these circles. Okay. So this circle located at the position z equals to 8. Okay. Equals to so we get 16, right? So this is a circle that has a radius of 4. Radius of 4. Radius 4. Okay, so we can draw this thing. Radius is 4. Okay, we can draw this thing. The radius is 4. Okay, so the dr will be from 0 to 4, 0 to 2 pi for the d theta. Okay. Right, so let's continue. Solve the integral. This one becomes 7z. This one becomes 14z squared over 2. You do it manually. Okay. 8 and also, yeah, okay, you do it manually. So all the z you replace with the 8 and also square root 4x squared plus 4y squared. Okay. So this one you can press calculator. Okay, minus 7. This one I can actually simplify, make it easier. Right. Okay, so this part don't have the square root because you square it. Okay, so you have the r, dr, and d theta. Okay, so I think at this stage you should know what you have to do. Right, so you have to convert it. Okay, you have to convert it into the r. So this one can become 504 minus 7 square root 4r squared, right? Plus 7 4r squared. And then you have a r outside. So I know the step actually is a lot of steps, but please write down properly, because if you jump the step, you might make mistake, and it's very difficult for you to trace back. You want to check later. Okay, so this one you could write it to be 504 minus 14 r, right? 28 r squared. Okay, it's okay.
Madam,
Yes.
yang tambah tu bukan jadi tolak.
Betul tolak. Okay, sorry, this one should be tolak. Yes, thank you for telling me. Okay, so this one should be minus. Okay, so you can press calculator directly. So you press calculator. Okay, so you get this. Okay. This thing is 11648. Okay. Okay, is that okay for you?
Okay, madam.
Right. So this is how you use the divergence theorem to find the flux. Okay, to find the flux. If the question didn't ask you to verify, you solve using the divergence. Okay, if they ask you to verify left hand side and also right hand side, both sides you have to solve it and then prove it. Prove the answer to be the same. Okay, so this is the exercise about the divergence theorems. We will move on to exercise 4K. Okay, for the Stokes theorems. For the Stokes theorem. So I want you to refer to exercise 4K, page 185. Let's try maybe question 2. We'll try question 2. Okay, the first one is verified. Okay, verified spend a lot of time. Try question number 2. Okay, just want to make sure that you know how to use the Stokes theorems. Stokes theorems. So what is Stokes theorem? Stokes theorem is actually transformations, okay, from the line integral. If you remember, this is the line integrals of vector field that we have solved before, okay, and we can transform it, okay, to the surface integral, okay, but here you need to perform the curl of the vector f and then dot product with the unit normal vector and ds. Okay, so basically the Stokes theorem is this one. Okay, you need to solve, okay, for the answer, okay, using these equations, the Stokes theorems. Okay, so question number 2, you have to evaluate, okay? You evaluate the line integrals of vector field by using the Stokes theorem, where the f is this one. So you record down the information given. F is 3y squared plus z squared. Okay, this is the I component. Okay, x squared, j component, and y squared. This is the k component. Right. C is the curve as the boundary of the plane, okay, in the first order in the counterclockwise orientation when observed from the top. Okay, so maybe C is the curve of the boundary of the plane. So maybe the first thing is you have to draw the plane first, because you want to imagine, right? Draw the plane first. So the plane has the equation x plus y plus z equals to 5. So this is a plane in the first order. So we draw this thing. Okay, if you divide both sides with 5, okay, because we want to make sure that this side is equals to 1. So meaning that all you will have intersections of 5. Intersection point of 5. Okay, so this is your plane. Okay, draw a plane and read again. Okay, C is the curve as the boundary of the plane, okay, in the counterclockwise orientation when observed from the top. Okay, so meaning that, okay, your C is this one. Okay, your C is this one. See the red one? The red color line. Counterclockwise orientation. Counterclockwise. Okay, counterclockwise orientations. Okay, you clear about the questions? So for the Stokes theorem is to solve the line integrals. That's why you need to identify how does the curve, how does the line looks like. Okay, so I'm drawing this red color line to represent the curve over here. Okay, Stokes theorem is to solve this one. Okay, let's to solve this one. Okay, we go to the equation of the Stokes theorem. So you have to find the curl of the vector f, okay, and find the unit normal vector, and also the ds. And ds. That is ds. So sorry, two integral only. Ds. Okay, so first thing we find the curl of the vector f. Okay, so let's do this thing. Who still have problem to evaluate or to calculate the curl? Anyone still have problem to calculate the curl? Okay, so let's calculate it. So I want everybody of you to try this thing. Okay, how to do this thing. So hide the first column. So you will have 2y minus 0. Okay. And here must be negative. Here must be negative. If you are using my technique, then here must be negative. Okay. 0 minus 2. Okay. Okay. So 2y, 2z, 2x minus 6y. Okay, so this is the curve of the f. Next is to find the n. But here the question didn't tell us what is the n, right? So we just use the n of the outward equation of n. Okay, outward equation of the n. meaning that is equals to fx.
Madam,
Yeah.
untuk formula ni dia akan bagi ataupun kena hafal?
Macam bagi. Saya rasa I think they will give you this this equation. This equation is given. This equation is given. I think this one also given. Let me check again. Next week I will let you know. The outward equation I think is given also.
Okay, thank you madam.
Actually, it's not difficult to memorize, right? I mean, if you do it many times, you should know that how does the this equation looks like. Okay, I double confirm with you next week during our lecture face to face. Okay, I want to check. Okay.
Okay.
Fy. Okay. Then 1. Okay. Okay, so this is the equation. I read many times. Okay, right. Next one is like the surface integral of the vector field already. Okay, so trying to find the f. Okay, so f is a surface. Okay, f is a surface. So the question already mentioned the surface. The surface is the plane, right? And the surface is the plane. So equals to z equals to 5 minus x minus y. Okay, so this one is just you move the x and y to the right side. Okay, and then your fx will be -1, very easy. Fy also -1. Okay, -1. So put it inside the equation. Okay, over here, equations, and then the ds. So the ds will be cancelled out, and then the left the dA. So left the dA. So I will write it out. Okay, so we go to the double integral. So we have the curl of the f. So just now the curl of the f is what? Is this one. So we write this. We write it. 2y, 2y, 2z, 2x minus 6y. See? Take note on the bracket. Don't just use don't use a round bracket. It's totally different meaning. Okay, and this one is 1, 1, and 1, and then dA. This one 1, 1, and 1 is from here, right? When you replace it here, you get this thing, and this thing will be cancelled out. Okay, so I don't write this thing. So dA. When it comes to dA, you have to pick from the projection. So for this plane, you have many choice of projections. You can pick XY projections. Okay, you can pick XY projection. You can pick the ZX projection. Okay, you can also pick the ZY projections. So it's up to you. So but here I want to use the XY projections. Very common one. Let's continue with the XY projections. So XY projection meaning that you look at the plane from the top. Okay, so you can see the triangle like this, right? Triangle like this. Triangle like this. So this is the XY projections. Okay, and these both points, they have a value of 5. Okay, they have a value of 5. Okay. So I think from this drawing, you should know what coordinate system you have to use, right? Because the shape, this is not circular shape, right? So we have to use the Cartesians. And since we choose the xy projections, so this one we can become dx dy or dy dx. So it's up to you. Okay, or dy dx. Right, so let me write again. Maybe we define the interval first. Okay, let's define the interval. If I want to use the vertical strip technique, do you still remember how to find the interval? If I use the vertical strip technique and horizontal strip technique, go to ds first. Okay, so you look at this straight line, vertical line, the red color line. So it can move minimum here and then maximum here, right, until 5. This red line. Okay, you can move it. Okay, so your dx will be from 0 to 5. Okay, and the dy is, okay, imagine you are sitting inside. When you refer down, you see this horizontal line. And this horizontal line is at the position y equals to 0. Okay, and when you refer up, you see this line, the slanted line. Okay, 청동. Okay, so this line does not have a fixed value. It depends on the value x. Okay, so it depends on the equation of the straight line over here. So you have to find the equation, this one. So this equation, you can get it from the equation of the plane. Don't worry, you can get it from the equation of the plane. So this is the equation of your plane. When you pick the xy projection, meaning that your z is equals to 0. Okay, so your so your y will be equals to 5 minus x. So this one will be the straight line equations for down here. Okay, down here, y equals to 5 minus x. So this one will be up to 5 minus x. Alright, is that clear? Okay, can you follow?
Clear, madam.
Yeah, right. Continue. We put our interval here. Remember, I told you before, number should stay outside. Okay, with the variable should stay inside. Okay, and this thing we haven't settled yet. Okay, 2y plus 2z plus 2x minus 6y. Okay, so we have the dy dx. Okay, we have the dy dx, and here you can see that you have a z. Okay, so the z should be replaced. Okay, replaced by what? Replaced by the equation of the plane. So 2y. The equation of the plane is z equals to 5 minus x minus y. Okay, 5 minus x minus y. Now this is the equation of the plane, plus 2x minus 6y. So this one, maybe we'll combine a bit first. Negative 4y. Okay, this one.
Madam, bukan 6y tolak 2x.
Sekejap, 6y tolak 2x. Sekejap. Mana saya silap? 2y tolak 6 kan? Tolak 6y kan? Sekejap. Ya dah yelah, boleh combine kan? Ya, boleh combine lah. Jika nak combine, kena, okay. Boleh je kan? Sekejap Solution. Then minus 2x minus 2y equal to 2x. It's up to you how you simplify it. This one and this one can be cancelled out. So it will be, yeah, right, correct. So it will be minus 6y plus 10. Yeah, dy dx. Okay, so finally we can start to integrate with respect to the y. So we get negative 6y squared over 2 plus 10y okay, So all the y you replace with this one. So negative 3y 5 minus x plus 10 5 minus x. Okay, so now you can press calculator. Yeah, power 2. Power 2. Yeah, power 2. So it is 0. Okay, so it is 0. Okay, so this is the Stokes theorem. How many groups want to present in these sessions? How many groups want to present later? No group want to present later? One group and then? One group only? Okay, so I'll just continue because one group only, right? So we still have time. So we continue one more example for the exercise 4K. We go to question Q3. Question Q3. 4K Q3. Okay. Question 3. Okay. Question 3. Use the Stokes theorem to evaluate the line integral if the f, so f given, so we write down the f given, x, z, x, y, and 3x, z. Okay. C is the boundary of the portion of plane in the first order oriented counterclockwise and upward. Okay. So the information given, okay, you have a plane, so 2x plus y plus z equals to 2, and then this is upward. Okay, so using the Stokes theorem. Okay, Stokes theorem is this one. Okay, Stokes theorem is this one. Okay, so first step, okay, go to drawing first. Okay, we draw the plane. So these 2x, you have to divide 2, right? Y divide 2, and the z also divide 2. Okay, because at the right hand side, you want to make it 1. Okay, so from here, you know the intersection point of the plane. So it will be 2, okay, 2 and then 1 here. Z is 2, Y is 2, this is 1. Okay. C is the boundary of the portion of plane in the first order. So, but here it didn't mention about clockwise or counterclockwise. So it means this one. So same like the previous one. This one. Okay, is this thing. Oh yeah, just now I mentioned that for the projections, you can pick the others. I think cannot. You cannot pick the others. You have to follow this. Follow the curve. Okay, if the curve, okay, is referring to the triangle in the xy projection, then you have to choose xy projections. Okay, you cannot simply choose yz or sz. Okay, same like this one. Do you want to try 5 minutes? I let you try 5 minutes. Okay, start from these equations. Okay, let's try 5 minutes, right? Is that okay?
Yeah, madam.
Okay, 5 minutes. Huh? Are you able to do it? Right, so maybe you can look at my solutions now. We do together. So we go to the final code first. Code. Okay, so for the item is 0 because you cannot differentiate. Okay. Next is to find the unique normal vector. Okay, so mention that is upward. So we use these equations. Okay, use these equations because it is upward. So let's find what is the F. So the F is the surface, okay, the surface of the plane. Okay, so we use this one, 2 minus 2x minus y. Okay, so this is the equation of the plane given by the questions. You just move the x and y to the right side and you can get this thing. Okay, next is to find the differentiations. Okay, fx you get -2, fy you get -1. Okay, -1. Right, last we can combine them. Okay, we can combine them. Do the double integral. So we have the curl of f, which is 0, -3z plus x, y, right? Dot product with the dot product with the n. So n we have 2, 1, and 1. Okay, then we have dA. Then we have the dA. Okay, so let's settle this thing first. So you have a -3z plus x plus y. Is it correct? And for the dA, okay, for the dA, you have to look at your C. Okay, you have to look at your XY projection. You see a triangle. So you see a triangle. Just remember the first. Okay, so it is 1 and 2. Okay, this is the y, this is the x. Okay, right. Okay, so here we will use the Cartesian coordinate system, so ds dy or dy dx. So if you're using the vertical streak, then it will be dy dx. Okay, so let's define the dx together. So the x value will be from 0 to 1. Okay, and the dy will be from 0 up to, okay, the equation of the line. Okay, the equation of the line. So with the equation of the plane is 2x plus y plus z equals to 2. So when the z is 0, okay, for the xy projection, your y is equals to 2 minus 2x. Okay, 2 minus 2x. So it will be 2 minus 2x. Okay, 2 minus 2x. Now you replace it inside. Okay, 0, 1, 0, 2 minus 2x, negative 3z. Okay, so the z you replace with the equation of the plane, which is 2 minus 2x minus y. Okay, and plus the x plus the y, dy dx. Okay, so let us simplify first. 6 plus 6x plus 3y plus x plus y dy dx. Okay, so this one is okay. So 6 0 1 0 2 minus 2x, negative 6 remain. Okay, plus 7x plus 4y. Okay, dy dx. Okay, now we do the integration with respect to the dy. So negative 6 become negative 6y, 7xy plus 4y squared over 2. Okay, so this is the integration with respect to the y. Okay, now all the y you replace with the interval value. Okay, for example, negative 6y, so 2 minus 2x plus 7x y is 2 minus 2x. Okay, plus, okay, this one can cancel out, become 2 minus 2x squared dx. Okay, so you can actually choose whether you want to expand it, okay, or you don't want to expand it. Okay, or you want to key the whole thing in your calculator, it should be fine. Okay, let's try to key in calculator. Negative 6. Plus 2 bracket 2 minus 2x. Answer is negative 1. Did I make mistake? Can you get negative 1? I'm going to do it one by one. 6. So it's -6.
-1 madam.
Yeah, answer is -1. Can you get it?
Dapat.
Dapat. Very good, if you can get. Okay. Okay, 7/3 -6. Yes, you get -1, eh? That's your answer. Okay. Right. And any questions? So we have tried exercises for the Stokes theorems, divergence theorems, eh? Okay, wait down. Right. So for the group that are going to present later, can you prepare? So we are going to the presentations, but before that, I would like to take attendance also. Set the attendance. Anyone from section 2?
We are from section 1, group 6.
Okay.
Dr. Section 2.
Section 2 also kan? Never mind lah. Section 1 first, Section 1 first because the